Sorry guys, I got cut off by the free software that I'm using. It has a limit of 15 minutes. But I'm back, and now we're finishing up our code, which we are trying to get zeros everywhere below the diagonal. And to do that, we are manipulating the function to where I'm multiplying and dividing and subtracting by certain columns, and I'll explain as I go. So here we're saying that y is greater than 3. Check the data above it. If that's equal to 0 and the data above that is 0 or does not equal 0, then we can work with that data, and we are subtracting the data that we want, which is the lower row, or the lowest row, not the lowest row, just the row that we're in, minus the data 2 rows above it, times the data that we're looking at divided by the data 2 rows above it. Can't really see. Close these parentheses, and we can continue. Else, if our data is only one less than the row we're in, that doesn't equal 0, then the data we're looking at sorry, that took a while. I had a test today. It was a pretty tough physics test, so I'm a little out of it, as you can see. But yeah, so we're just going to go along the rows, seeing where they're at and seeing what will get rid of these rows, which is ultimately what we want. Not get rid of the rows, rid of the numbers under the diagonal. So here we just keep coding it for that, minus the data, y minus 1, or not x, that whole row, times the data. In divided by data of I minus 1 else if y is greater than or equal to 4 and data y minus 2 of that. I'm missing parentheses here. X is equal to 0 and data 3 above that row does not equal 0. Then we can work with this row. We say data y rows is equal to data y of all rows minus data y minus 3 x times. It's essentially the same process for each row. You're just working with different rows. Data y x divided by data minus 3 x. And if that fails, you find where there is no 0 in that column. You say I equals find where data of all rows certain column does not equal 0. Okay. And that should be your upper triangular form. Let's go ahead and try that. So we'll put in the example. We're gonna say one. Hang on, let me pull up. Oh, you know what? I forgot to name our output. Upper equals data. Yeah, so here we have bear with me, guys. I know it's saved somewhere up here. Oh, maybe not. I'll just look for it online. Okay. So we have 1034. 1034. 1, 2, 1, 3. Let me get that last row. 0612. 0612. And we output our data. Wow, it is not working. Do we? Oh, well, it seems as though I forgot to call my function. Oops. So here I call upon my function. We want our upper. That's for our upper triangular form. We send our function to upper triangular. We import our data. And let's actually see what that gives us. No. Not input arguments. Oh, geez, where's my head today? Row, column, data. And there we go. We have our upper triangular form for our problem. And as you can see, say we had some 0 all upon 0. Let's change, I don't know. Let's move our numbers around. Let's call this a 5, and this one is 0, and this of 6. We still have our upper triangular form. See, it works for other matrices. So now what's left to do is to find out our coefficients. First, let's display our matrix a little nicer. Let's say the upper triangular matrix. The upper triangular matrix is display, and then you display your upper matrix. So let's run this again, and again, this is just to make it look nice. There, suppress that. My bad. There we go. Looks a little nicer. So what's left to do is to back sub our numbers to get our coefficient values, and I'll go over that in the next video.